A second order mechanical system is represented by the transfer function theta of s upon I of s equal to 1 upon a step input of 10 Newton meter is applied to the system and the results are given below. The maximum overshoot is 6%. Maximum overshoot is 6%. MP. MP equal to what? 6%. Therefore, 100 e power minus zeta pi upon square root of 1 minus zeta square. That is equal to 6%. Time at peak overshoot, PP, equal to 1 second. TP, what is the formula? What is the formula? Pi upon omega n square root of 1 minus zeta square. That is equal to 1 second. Steady state value of the output. Theta steady state. Steady state value of the output equal to 0.5 radians. It means second order mechanical system. We do not know the nature of the system, whether it is underdamped, overdamped, critically damped, undamped. It is not undamped because it is settled at 0.5. Therefore, any one of these three categories, overdamped, underdamped, critically damped, it is settled somewhere. Let us assume that it is underdamped, it is settled somewhere. That value is 0.5. That is given. Finally, it is settled at 0.5. The steady state value of the output is 0.5 radians. This is given here. Determine the value of J, F, and K. Determine the value of J, F, and K. First, it is given that MP equal to, that is 100 e power minus zeta pi upon square root of 1 minus zeta square equal to 6. From that, we can find zeta. So, this can also be written as e power minus zeta pi upon square root of 1 minus zeta square equal to 0.06 or minus zeta pi upon square root of 1 minus zeta square equal to ln of 0.06. So now we have to find zeta square. What is the value of this? Equal to minus 2.8134. So both the minus signs getting cancelled. Therefore, zeta square pi square upon 1 minus zeta square equal to 2.8134 whole square. Find zeta. .667. Zeta equal to 0.667. This implies zeta square pi square equal to 2.8134 whole square minus zeta square 2.8134 whole square. From this, we can find zeta. Zeta equal to 0.67. Therefore, underdamped, what we have assumed is correct. Underdamped system. Underdamped system. Then time at peak overshoot, TP equal to pi, TP equal to 1 second. That is, this is first part. The second part is pi upon omega n square root of 1 minus zeta square equal to 1. Already we know the value of zeta. Therefore, we can find omega n. Omega n equal to pi upon square root of 1 minus zeta square. We know zeta, 0.667. Find omega n. Find omega n. $4.217 omega n. Now we have to compare steady state value. Steady state value theta SS equal to 0.5, that is given. For what? Input 10 newtons per second. It is given that theta of S upon I of S equal to 1 upon J square S square plus Fs plus K. I of S is given. I of S equal to what? I of S equal to 10 upon S. Because step input means if you take Laplace transform for that step input 10 upon S you will get. Therefore, I of S equal to 10 upon S. If you substitute this here, what you will get is theta of S equal to 10 upon S multiplied by J square S square plus Fs plus K. That is theta. We have to find final value. We know the final value theorem. What is final value theorem? You studied in signals and systems. J. Yes. Thank you. J. Final value theorem states that y of infinity equal to, or we can write like this. Limit t tends to infinity, y of t equal to, we can say y of infinity also. Limit t tends to infinity, y of t equal to, that is the final value, equal to limit s tends to 0, s y of s. If you know y of s, we can find y of infinity, that is equal to y of infinity. Here I am using caps y in S domain. In time domain, I am using small y. We can find y of infinity by using this final value theorem. So here we know theta of S. Theta steady state means equal to limit t tends to infinity, theta of t, that is equal to limit s tends to 0, s theta of s, by using final value theorem. Limit t tends to infinity, theta of t equal to limit s tends to 0, s theta. That is final value theorem. So if you apply that final value theorem here, we will get theta of infinity. Theta of infinity equal to limit s tends to 0, s multiplied by 10 upon s js square plus fs plus k. These two getting cancelled. S getting cancelled. If you substitute s equal to 0 here, what you will get? 10 upon k you will get. This is given. The value is given. What is that? Steady state value is 0.5 radians. It is given. Therefore, 10 by k equal to 0.5. 10 by k equal to 0.5. Theta of infinity equal to limit s tends to 0, s, theta of s. Theta of s equal to what? 10 upon s, j s square fs plus k. S getting cancelled. If you substitute s equal to 0, s equal to 0, this becomes 0 and this also becomes 0. Therefore, it is equal to 10 upon k. That is given. What is the value given? 0.5. That is 1 by 2. Therefore, k equal to 20. 10 upon k equal to 1 by 2. Therefore, k equal to 20. Now we got one answer. Find the value of k is asked. Find the value of k is asked. We found only we have to find the j and f we have to find. Determine the values of j, f and k. One unknown, that is k is we found. K we found. J and f we have to find. To find j and f, compare this transfer function with the standard one. Compare this transfer function with the standard one. What is standard transfer function? Omega n square upon s square plus 2 zeta omega n s plus omega n square equal to, what is given? 1 upon j s square plus f s plus k. Therefore, coefficient of s square must be 1. Here, coefficient of s square is not equal to 1. Therefore, we have to rewrite this as 1 by j whole divided by s square plus f upon j s plus k by j. Omega n square equal to k upon j. Omega n square equal to k upon j. One equation we got. 2 zeta omega n. 2 zeta omega n equal to f. F. Therefore, f by j. 2 zeta omega n equal to f by j. Therefore, we know zeta. We know zeta. This is second equation. This is second equation. That's all. From these two, already we know one value. Two equations we have, two unknowns we can find. Number of unknowns and number of equations are equal means we can find. Now, what is k? What is the value of k? K equal to 20. Therefore, we can substitute k value, zeta value. Whether we know zeta value 0.667, that is also we know. If we substitute that, we'll get j and f. We can find j and f. Find j and f. Because we know that k equal to 20 and zeta equal to 0.667. That we know. So find f and j. Omega n also we know. Sorry. What we found here, omega n. Omega n equal to 4.217. So these two we know. Omega n we know, zeta we know. So we can find KJF. K by J equal to omega n square, that is 4.217 whole square. That is equal to that is equal to 20 by J, because K also we know 20. Therefore, J equal to 1.124. J equal to 1.124. F by J equal to 2 zeta omega n. 2 into 0.667 and omega n equal to 4.217. Therefore, J also we know, F upon J equal to 1.124 equal to 2 into 0.667 multiplied by 4.217. Therefore, F equal to 6.323 Newton per meter per second. This is a Dashford constant. B equal to 6.323 Nm Newton per meter per second. Consider the unit step response. Consider the unit step response. It means what? Input R of S equal to 1 upon S. G of S is given. Unit step response. Therefore, the input is 1 upon S. Of a unity feedback system. So it is closed loop system, closed loop feedback system, whose open loop transfer function is G of S is given. That is 1 upon S multiplied by S plus 1 is given. But the system is closed loop. The given system is open loop transfer function. Therefore, closed loop transfer function T of S equal to G of S upon 1 plus G of S H of S. Here H of S equal to 1. Why I said 1 H of S equal to 1? Why H of S equal to 1? Here it is given that unity feedback system. Indirectly, they are saying that it is H of S equal to 1. Unity feedback system means, suppose I am having a system R of S. This is G of S. This is given. What is given? 1 upon S multiplied by S plus 1. This is given. This is C of S, output. The feedback is unity feedback system. Here 1, the transfer function of H of S equal to 1. Unity feedback system. Always in control system, they didn't mention about feedback. You have to take negative feedback only, unless otherwise specified. If they said positive feedback, then only you have to take positive feedback. Otherwise, you have to take negative feedback only. So unity feedback system means unity negative feedback system. So this is minus. Therefore, the formula is 1 plus. The formula is 1 plus. Why 1 plus? Because negative feedback. Unity feedback, that's why H of S equal to 1. Therefore, the transfer function T of S equal to G of S upon 1 plus G of S. Hereafter, we need not write H of S if it is a unity feedback system, because H of S equal to 1. If it is a unity feedback system, no need to write h of s. Directly we can write g of s upon 1 plus g of s we can write. This is for unity feedback system. What is a g of s? G of s is given 1 upon s multiplied by s plus 1 whole divided by 1 plus 1 upon s multiplied by s plus 1. S plus 1. Therefore, if we take LCM, what you will get? 1 upon s multiplied by s plus 1 whole divided by s multiplied by s plus 1 plus 1 whole divided by upon s multiplied by s plus 1. These two getting cancelled. Therefore, T of s. Therefore, T of s, the given transfer function is 1 upon s multiplied by s plus 1 plus 1. That is equal to 1 upon s square plus s plus 1. S square plus s plus 1. That is given. That's all. These steps you have to do. Why we have to do all these things? TFS is not given. Closed loop transfer function is not given. Open loop transfer function GFS is given. That's why we have to find TFS, then we have to proceed the sum. If we directly use this, you will get wrong answers. This is open loop. This is open loop transfer function. We have to find closed loop transfer function using 7th rule. Now we have to compare this with the standard transfer function. What is standard transfer function? Omega n square upon s square plus 2 zeta omega n s plus omega n square. Here coefficient of s square is 1. Here also coefficient of s square is 1. Therefore, we can compare the other things. Omega n square equal to 1. Therefore, omega n equal to 1. 2 zeta omega n equal to 1. Therefore, zeta equal to, if you substitute omega n equal to 1, you will get zeta equal to 1 by 2. That is equal to 0.5. Omega n equal to 1. What is the final answer? Find peak time, maximum overshoot, settling time for 2% tolerance. These are all asked. These are all asked. The first question is peak time. TP. TP equal to peak time equal to pi upon omega n square root of 1 minus zeta square. That is equal to pi upon omega n square is 1 square root of 1 minus 0.5 square. Find 3.62 seconds. Maximum overshoot, MP is asked. Raise time also asked, I didn't notice. We'll see. Maximum overshoot, MP. MP equal to what? Formula. Percentage. If you want to tell in terms of percentage, 100 e power minus zeta pi upon square root of 1 minus zeta square equal to 100 e power minus 0.5 multiplied by pi square root of 1 minus 0.5 square equal to MP equal to how much? 16.3%. Then we have to find settling time. Settling time, TS. Settling time for 2% tolerance. 2% tolerance equal to 2% tolerance equal to 4 upon zeta omega n. That is equal to 4 upon 0.5 omega n equal to 1. That is equal to 8 seconds. 8 seconds. Now we have to find raise time, TR. Raise time means what? Suppose this is the response means, this is the response means, this is the final value. This is TR, raise time, TR. This is TP, this is TP, peak time. This overshoot in percentage of final value is MP. This is settling time, TS, 2% tolerance. So TR we have to find. TR equal to what? Pi minus pi upon omega n square root of 1 minus zeta square. You have to find pi in terms of radians mode. Put the calcium radians mode and then find. Phi equal to what? Tan inverse of square root of 1 minus zeta square upon zeta. That is equal to square root of 1 minus 0.5 square divided by 0.5. Tan inverse of. Find arctan. TR equal to pi minus tan inverse of 1 minus zeta square upon zeta. That is equal to 60 degree. But we should not write 60 degree because it should be written here in radiant mode. That is very, very important. You should not find in degree mode. Pi by 3 you will get. So you substitute, you will get 2.42 seconds. 2.4. Got check whether it got 2.42 seconds. Got 2.42 seconds. Consider the closed loop transfer function given by. Closed loop transfer function is given. T of S is given. Determine the value of zeta and omega n so that the system responds to a step input with approximately 5% overshoot with a settling time, approximately 5% overshoot with a settling time of 2 seconds. Settling time of 2 seconds. Settling time of 2 seconds. Overshoot, we have to find omega n and zeta. These are the two unknowns here. Omega n and zeta are the two unknowns. Zeta equal to what? Omega n equal to what? We have to find. 5% overshoot. MP equal to what? Percentage MP equal to 100 e power minus zeta pi upon square root of 1 minus zeta square. That is equal to 5 given. If you substitute, automatically you will get zeta. Find zeta. So what you will get? E power minus zeta pi upon square root of 1 minus zeta square equal to 0.05 or minus zeta pi upon square root of 1 minus zeta square equal to ln of 0.05. You will get negative value. That's why negative sign will getting cancelled. ln of squaring on both sides and finally find zeta. Zeta equal to what? 9. Same value. 0.69. In the previous sum, we got 0.6678. Here 0.69, zeta equal to 0.69. And another settling time is given. Ts equal to, let us assume that it is 2% tolerance. Tolerance is not given. If it is not specified, we have to take 2%. So 4 upon zeta omega n equal to 2 seconds. Omega n equal to 4 upon 2 zeta equal to omega n. Omega n equal to 2.896. So here it is directly the closed loop transfer function is given. Sometimes instead of asking like this, they will ask, write the transfer function and find the unknown parameters in the transfer function and then find the step response. Sometimes they will ask. In that case, the step response equal to what? 1 minus e power minus zeta omega n t sine omega dt plus 5. 1 minus zeta square. That is equal to what? 1 minus e power minus zeta equal to 0.69. Omega n is 2.896 t divided by square root of 1 minus zeta square 0.69 square sine omega d. Omega d is omega d equal to omega n square root of 1 minus zeta square. That is equal to 2.896 square root of 1 minus 0.69 square. You find and substitute here omega dt plus phi, where phi equal to tan inverse of square root of 1 minus zeta square upon zeta. Like that you can write. Sometimes they will ask you to find the step response. Instead of asking zeta and omega n, find the step response. Unit step response.